Imagine numbers are like building blocks. Some are simple, like 1, 2, 3. These are natural numbers, represented by everyday fruits. If you add 0, they become whole numbers. Here's 0, represented by a toy die. Now throw in negative numbers like -1 and 2 and a 3, and you've got integers. These are shown with minus signs. Fractions like 1/2 or 3/4, and decimals that either stop, like 0.5, or repeat, like 0.333, are rational numbers. They can be written as a fraction. Irrational numbers are weird decimals that never end and never repeat, like pi, or the square root of 2. Real numbers are everything, all the numbers you can think of, including those weird decimals that never end and never repeat. So, real numbers equals rational numbers plus irrational numbers. Prime numbers are like the atoms of numbers. They can only be divided evenly by 1 and themselves. Examples include 2, 3, 5, 7, and 11. Prime factorization breaks down any number bigger than 1 into a multiplication of prime numbers. For example, 12 can be written as 2 times 2 times 3. Let's see the process step by step. Start with 12, divide by the smallest prime 2 to get 6. Then divide 6 by 2 again to get 3. Finally, 3 is prime, so we're done. The prime factors are 2, 2, and 3. The fundamental theorem of arithmetic states that every number has exactly one unique prime factorization if we don't count rearranging the order. Think of it like a number's unique DNA. Knowing prime factorization is super useful for finding the highest common factor and lowest common multiple of numbers. This helps solve many mathematical problems. The highest common factor, or HCF, is the largest number that divides evenly into 2 or more numbers. Think of it as the biggest number that both numbers share as a factor. Using a Venn diagram, we can see the factors of 12 and 18. The overlapping region shows their common factors, 1, 2, and 3. The largest is 6, so HCF of 12 and 18 is 6. To find HCF using prime factors, break each number down. For 12, 2 times 6, then 6 is 2 times 3, so 12 equals 2 squared times 3. For 18, 2 times 9, 9 is 3 squared, so 18 equals 2 times 3 squared. The HCF takes the lowest power of each shared prime. Here, 2 appears once in both, and 3 appears once in 12 and twice in 18, so lowest is 1. HCF equals 2 to the power 1 times 3 to the power 1, which is 6. The lowest common multiple, or LCM, is the smallest number that both numbers divide into evenly. Imagine two gears that need to mesh perfectly. They need a common multiple to align. Here we see multiples of 12, 12, 24, 36, and multiples of 18, 18, 36, 54. The smallest number that appears in both lists is 36, so LCM of 12 and 18 is 36. Using prime factors for LCM, take the highest power of each prime. For 2, 12 has 2 squared, 18 has 2 to the power 1, so highest is 2 squared. For 3, 12 has 3 to the power 1, 18 has 3 squared, so highest is 3 squared. LCM equals 2 squared times 3 squared, which is 36. The Euclidean algorithm is an efficient way to find HCF. Start with 48 and 18. Divide 48 by 18 2 times with remainder 12. Now find HCF of 18 and 12. Divide 18 by 12, 1 time with remainder 6. Now HCF of 12 and 6. Divide 12 by 6, 2 times with remainder 0. Since remainder is 0, HCF is 6. There's a special relationship between HCF and LCM. HCF times LCM equals the product of the two numbers. For 12 and 18, 6 times 36 equals 216, and 12 times 18 is also 216. To prove Q2 is irrational, use contradiction. Assume STR2 equals P over Q in lowest terms. Square both sides, 2 equals P squared over Q squared. Multiply both sides by Q squared, P squared equals 2Q squared. This means P squared is even, so P is even. But if P is even, Q must be even too. This contradicts the assumption that PQ is in lowest terms. Therefore, 2 is irrational.